All right. Hey, folks. Welcome to Semantic Rag and Practice. My name's Drew Wanczowski. I'm a senior principal with Progress Software. I have a background in information management. Been doing this for almost 20 years now, mostly on the metadata side, information retrieval and knowledge graphs, working in scientific publishing, R&D, and media and news. I have my colleague here, Morris, as well.
Hi, yep, Jim Morris. I'm also a solution engineer, work with Drew on that team at Progress. I focus on the semantic side of things, so I have a background in library and information science. I've worked in that field for a long time, most of that time in pharmaceuticals. So if I start to stray into life sciences examples, that's why. But thank you all for coming.
So this is going to be a little different than some of the other workshops that you might have seen in the last day. We're going to go over a couple of layers, and we're going to focus mostly on the architecture side. There'll be some code examples and building of knowledge graphs. But I think it's important to really focus on the architecture. When you're in an enterprise, there's a lot of different things to take into consideration, whether it's security, provenance, data lineage, all that, before you even start to throw your information at an LLM, right? And what we're looking at is how do we build accurate and traceable and transparent AIs. Just a little bit about Progress Software. We've been around for about 40 years. We have products across the stack, all the way from infrastructure like Chef and Flowmon, all the way up to user experiences like Kendo React. What we're going to talk about today mostly is around the Progress Data Platform, and that is in that middle two boxes around information management, semantics, and multi-model data management. Progress's main client base is around the 500 companies. We do help a lot of small and medium companies as well. But some of our claims to fame are healthcare.gov. When you sign up for an insurance through the US government, you're interacting with one of our systems, right? Bringing in metadata and information to determine your eligibility from state and local information all the way up to federals. In the FinServ side of things, billions of dollars of transactions a day run through our systems. And then in pharma and R&D, 7 of the 8 large pharmaceutical companies use Progress Software in some capacity. So we're going to talk about AI workflows and how to make them more trustworthy in the age of AI, as well as go through a demonstration of a sample application that you can construct using multi-model data, as well as knowledge graphs that pertain to this area. Once we go through that, we're going to start to peel the layers back and talk about how do we build knowledge models and knowledge graphs and use those for auto classification and adding context. And then we're going to talk about the data integration side of things and how to query things to make sure that you're bringing the most relevant content to the context for the LLMs. So as you'll probably know already, there's a lot of concerns with using large language models off the shelf, right? Things like hallucinations, data biases, lack of understanding, data cutoffs, explainability, robustness. And when you're operating in regulated industries or industries that people's lives are on the line, you don't want to make a rash decision just because an AI told you so, right? So we try to mitigate this as much as possible using a few different paradigms. And when we're talking to our customers, accuracy, expertise, adaptability, compliance, timeliness, and good user experiences are all top of mind, right? It's a lot of things to think about when you're engaging in a new project. And one of the things that we notice in these areas, there's a common thread that a lot of the information that folks are managing in their enterprise is domain-specific knowledge, and it's not necessarily in a neat table or database somewhere. The IDC projects that 80 to 90% of the world's data is going to be unstructured. And in the age of AI, that's a huge amount of fuel for these new systems, right? You're having all your information spread out across your enterprise. But if you can harness that and use that in context for your context, you're going to get a lot better results. And from an architectural standpoint, we start to look at this in a multi-model approach where we realize that some data is in relational databases, some data may be in your ERP systems or in mainframes, as well as industry standards that you want to bring in from your particular domains, like categorization systems, like medical subject headings that we're going to look at a little bit, or ICD codes, or XNOM, or if you're in finance, like FIBO, for example. All that together starts to build a data ecosystem, right? Where you need to manage it and understand it and start to build knowledge on top of it. And one shape, one size doesn't fit all. Trying to put everything into a single data model is not necessarily the best approach. So that's why we tend to take a multi-model approach with these things. In the middle here is what we look at in our data platform. And high level, these are architectural things that we think everybody should look at, whether you're using our platform or not, is things about when you engage with agentic and semantic AI, use that as a tool to start to make sense of your data, right? But in an enterprise where your data is your lifeblood, you need uniform security to make sure there's no breaches and data leaks, right? You need a governed data model to ensure that everybody's speaking the same language. You need reference data and metadata to keep it organized and keeping track of it. You may need to do semantic analysis and enrichment on top of the data because it's wildly unstructured and you need to build bits of information to find it more easily or prepare it for use in an downstream application. And then certainly you may have business rules that you need to encode that have to run the same way every single time in a deterministic way, not a statistical way, right? So once you start to understand these parts of the ecosystem and the architecture, when you manage all that data, now you can reuse it in a lot of different ways. And AI is a consumption pattern, really. It's how, like, the majority of people that engage with it are using it for consumption, whether it's a chatbot or an agent. So you can use that data now in those AI workflows or use it in transactional apps, data exploration, your traditional data services and APIs or analytics, right? So we're going to look at how we can prepare that data in that way so we can use it in all those different categories. And once you have that data like that, the types of applications that we typically see is content creation, where you're building new information, whether you're a publisher building a new article or a book, or if you are a researcher doing analysis on a new chemical or drug, right? Or you're doing deep research where you need to look through tons and tons of articles and do like meta-analysis, for example. Customer 360s, where you need bits of information that are in other systems, but you want to connect them together to create a holistic picture. And now a lot of agentic assistants where we're creating tools on top of the system, like whether you're using a traditional RAG approach or MCP, right? The data platform is also augmented by this AI layer here, whether in our case, you can do a fully supported SaaS solution where Progress Agentic RAG, or you can use our data platform as a build your own setup using industry standard frameworks such as LangChain. So at a high level, when we start to interact with the AIs and doing question and answering, a user is going to have some kind of query or an agent is going to have some task that they're looking for, right? So the first thing we're going to do is analyze that request and determine what's their intent, right? Look for what the semantic meaning of that question or bits of content they're looking for. We're going to augment that question by looking in our solution, in our data stores, for contextually relevant information and pull that out. As we went through that workflow, we're governing and validating it and making sure that we're sharing the right data with the right people or right agents in this case. And then we annotate that original answer, add that additional context, and let the LLM do its magic, right? And this high-level workflow has allowed us to put into production a lot of interesting applications at our customers. They have been increasing their levels of accuracy a tremendous amount, whether they're in pharma, R&D for chemical productions, whether they're doing tax code research, et cetera. So the application of knowledge graphs has really accelerated the level of accuracy, because at the end of the day, the context is where we win. Understanding where the intent of that question is coming from, as well as the information that you have inside your organization to answer that question. So going into the workflow a little deeper, we have content coming from different sources, right? It may be a PDF, it may be a Word doc, it may be an email or a research article, right? So what do we do with that? We take that content and we break it into logical chunks, right? So there's various ways to break those pieces of content up, but you want to break them up in a way where you have some overlap as well as adding contextual information into that, right? And we do that, adding that contextual information by doing a semantic analysis over a projected schema, as well as having information from our knowledge graph to analyze that text that's coming through, to classify it, to add that metadata and that context and link it to the knowledge graph. And when we store that information, now we have the semantic links to the knowledge graph plus the information that's in those records. So it's not necessarily sharding everything and sticking it into the graph. It's using a mixed model where we can use the underlying unstructured data plus the knowledge graph to understand where we're going. So on the right-hand side, when you're seeing the traditional Q&A, when it hits the AI services, it understands what to do based off of that information that's in there. So we take that intent, we use that same knowledge graph that we use to categorize and classify the content to interpret the intent of the user's question. But since we have measured using one approach for search and discovery is not necessarily the best approach, because you can leave other things on the table, right? So taking a hybrid query approach where you use a semantic analysis, a knowledge graph traversal, plus traditional lexical relevancy-based searches and vector-based searches to find content has proven pretty valuable to our customers. So as we go through this process, and when you think about going your own projects, here are some things that we think about that may help you as well. So in data preparation, bringing those that content in and defining canonical business entities, right? What are the particular domains and encapsulations of the information that you want for your particular project, right? Since we're looking at a larger ecosystem of data, there's going to be data duplication, right? A customer in system A may be a customer in system B. So you can use fuzzy matching and other methodologies to do data deduplication. We call that smart mastering, where we can automatically merge records or introduce a human in the loop where they can determine if it is a valid process to execute to merge those records. Being in the semantic space, there is a standard called Provo that you can use in conjunction with workflows to monitor way that data is being manipulated. So going through the process, understanding, capturing the actions that are happening through workflows, the influencers of those workflows, plus the data changes. And you can capture that at a higher level or a more granular level if you need field by field auditing, right? So that's one of the ways that we enable transparency, right? Is looking at that provenance graph to say who touched things, when, where, by what process, right? Knowledge model management, this also falls into the knowledge graph space, but it could be something as simple as a controlled vocabulary, a taxonomy, or just a list of terms, right? It's important that every part of the organization is speaking the same language. As another area where you can introduce a human in the loop is at that Q&A section by analyzing the incoming questions with an AI model to determine candidate terms and candidate information that you may want to put back into your knowledge graph. And by taking all that and just adding it into a graph, it could be kind of cumbersome and also add a lot of noise. So this is a logical place where to add an SME into the workflow where they can validate, understand what's coming in and the intent of these questions, and add that to a highly curated model. So there's been also a lot of talk about using AI to generate models and generate knowledge graphs. While that is good, again, LLMs are always statistical, right? They're non-deterministic on what's going to come out. So part of that is introducing the LLM to assist you in that initial build, but capturing that snapshot and then managing it from there with your SMEs, right? Where you can use it to accelerate your first go around, and then use that model and lock it down so it can be auditable and deterministically classify content using other methodologies such as natural language processing and entity extractions. RBAC is one of the things that also is to really look at before you go into your projects. A lot of the MCP pipelines now allow you to do things like OAuth, right? Where you can authenticate before you go into a session. Knowing the incoming user and what they have access to in the data is extremely important. So in our cases, some of the data that we have in these systems contain PII, HIPAA, PHI information. It may be information that requires a security clearance to see. At that point, you have to ensure that the data that's going to the LLMs still match those credentials, right? You don't want to leak sensitive information out where in the worst case, somebody can get information by engaging with an agent maliciously, right? So locking down items at a record level all the way down to a field level. And as this is going on, think about the audit trails on how you're going to map these out and understand who's doing what, when, where, by what systems, what incoming applications, and also if they are trying to do any modifications, right? So with the advent of agents and MCP, you can do back and forth, right? Not only querying, but you can start to do writings back to the system. So you want to ensure that you can track those interactions as well. So at the heart of this is really knowledge graphs, right? We have information that is in disparate systems, other areas of the business where it could be literally in a hard drive under somebody's desk, right? But it's valuable. And one of the things that we see continuously across our customers is pulling this information and putting a lens over it is extremely valuable. A report that they went to an analyst for would cost $200,000. If they can't find that, they're out that money, right? They have to re-engage. Or if you have to run a whole trial again, right? Because you lost important information from there, it's going to be an issue and could potentially be millions of dollars, right? So the knowledge graphs allow you to interconnect the data, whether it's structured or unstructured, and put a new semantic meaning on top of everything. Which leads us into the demonstration. So how do we look at an end user application that somebody can interact with to look at these vast amounts of information that are siloed, right? We're going to look in this demo at a few areas, specifically through that workflow that we were talking about before. And we're going to look at multi-model data in context. In this case, we're going to look at research articles that are coming from the NIH, specifically PubMed. We're going to look at a common terminology and vocabulary. The NIH also publishes medical subject headings, MESH, that we can look at to categorize and organize the information. The semantics capabilities are also going to unlock a few different insights into the data, as well as drive discovery and enhance our workflows. So you're looking at a demo application right now. And as I was saying earlier, AI and chat integrations and agents is one consumption pattern that you could put on top of your data. But as of today, everything is not replaced with an agent, right? You still have to manage that data in ways that you can do your traditional application development and application delivery to your customers. So if I do a simple search for glucose and GLP-1s, we have our traditional relevancy-based search. We can do things like two different relevancy models in the platform, whether it's TF-IDF or BM25 ranking for articles in terms of relevancy. This finds the content and allows you to index on metadata. Under the hood, these articles are XML. They were directly from the NIH data feeds. So they do have a certain set of metadata associated with them that we can aggregate and fast it down quickly into. One of the things too that you see on the right-hand side is starting to bring in contextual information, right? So as a user is interacting with the system, this is a key part where you can start to look for intent, what they're searching for, look for key concepts that they may either be asking the system for or based off the content that's being returned, bring in panels of information, right? So you're managing preferred labels, definitions, maybe additional media and references to a concept, and you can present that to your end users where they can consume that information along with the content. Drilling down into records, people are interested in the classification and knowledge graph side of things, but they're also interested in the full text, right? We can't lose sight of why people are looking for this data, right? It's usually in a research capacity. They need to read through the content, understand it, etc. What we can start to see here was that the article starts as a jumping off point and goes into other semantic categories, right? So when you come into a piece of content, you can go into other terms, discover other bits of information that you may be interested in. Introducing vectors, as well as this semantic layer, you can start to drive recommendation systems, right? Looking at the content that's within the system, using those language models to do an encoding of the textual information in there, and doing similarity searches to start to find other content that may be relevant to that bit of research that your user is looking at. Not all users want to come in and search for a bit of information. They may want to do more of a discovery style. And using your knowledge graph in terms of traversal and predefined categories for users to browse through is really helpful as well. So going through things like chemical and drugs, enzymes and coenzymes, we can start to follow the chain in our knowledge graph and then find contextually relevant content associated with these tags, right, or concepts. What's useful here is that in this case, this is a single query going against a single platform in this case, where we're combining both graph query and lexical search at the same time. Another thing, it may be content analytics, right? You're going to drive insights off of this information, and you may need a higher level roll-up of this data to audit the workflows that you're going through, as well as other aspects of your data ecosystem. So again, data, different lenses, different use cases, but that same strong foundation. And then finally, interacting with AI. I'm just going to ask, what is the effect on glucose while using GLP-1 medications? Going through that semantic analysis of the question, plus the vector vector embeddings, we can pull relevant content up to the top using a hybrid scoring model. And this has been proven to be pretty effective in our research, as well as industry research. So retrieving that information, adding that context to the LLMs, plus having the citational references back is another area of trust that you can build with your applications and give that to your end users. So while getting an answer back from the AI may be great, they can always go back and verify that it is the case by looking at the research themselves. So really what we're trying to do with this combination of knowledge graphs as well as multi-model data is to eliminate the fragmented knowledge, right? Users don't really care about what's the underlying technology when they are tasked with coming up with a new drug or analyzing a fraud case, right? They just want the right answers to them as quickly as possible. One of our tech leads at ADM implemented our solution and found that it transformed their process in R&D from bottom to the top of the organization, right? Being able to find these bits of information and knowledge as the workforce is transitioning, whether there's new people coming on board or people leaving organizations, is really important, right? Ensuring that knowledge is always captured and retained within the organization for further reuse is important. And we were able to then unlock additional insights and discover content through a well-governed and secured methodology, right? So after we go through this whole process, the next layer is how do we describe and start to build these knowledge graphs, right? And Jim is going to come up and kind of lay the foundation on what our approach is with this, and then we'll go into some more hands-on on building the models.
Thanks, Drew. Yeah, well, I'm going to go into a little more detail about some aspects of what Drew has been describing, maybe from a slightly different perspective. And, with just getting back to the basics, here we are at the conference of knowledge graphs. What do we mean by that? And what do we mean by kind of from a progress perspective and what we see in our projects? And so this slide really I think it really kind of summarizes our perspective on this challenge. So for example, when people start a knowledge graph project, usually they're starting with data that's amenable to this type of operation, data from databases. So, rows become nodes, columns become edges, and it's easy to bring this information into a system and work with it. But of course, the data doesn't just automatically connect with each other. You need to bring in some type of knowledge model, some type of ontology to make those connections. But of course, it's not always that simple, is it? So if your data doesn't know anything about your ontology and your ontology doesn't know anything about your data, there's no connection. So, for example, at one of our projects, we should stay near our microphone. One of our projects, we came in to build their semantic layer, and they said, "Oh, we've got an ontology. We're ready to go. Here's the ontology. Build out that layer, classify your data and everything." And it was an ontology. It was valid OWL ontology. It represented their business very well, but it had no labels. It had no evidence for what these things were. So there was no way for it to connect to the data because there's no link between the two. So we enriched their model, their ontology, with a public ontology that was rich in synonyms, because it was a chemical manufacturing use case. So there's other public models that cover the basics of chemicals. So they would use that and map that to their ontology. And then we're able to use the evidence from the public ontology to find the rows and the nodes in the graph that correspond to the public concept. But then we tag that data with their ontology. So now their ontology was able to make the connections. You could see the data from different perspectives. Let's look at it from the public perspective. Let's look at it from our specific ontology of interest. Another example, kind of from the other perspective, we're working with a very large knowledge graph project where they're trying to work with millions of rows of data from all kinds of different sources, very heterogeneous, and sometimes they don't even know what it is. So they're using an ontology models, and they're using many ontology models, public models. This is a pharma use case, so they're using all the standard players in that space, Mondo, Uberon, tissues, routes of administration, genes, proteins. And so all of this is in Semaphore, so that as this data is streaming through the process, Semaphore looks to see, do I know anything that's in this property? And if I do, let me mark it with the appropriate authoritative ID. And it speaks to the scale of what we're processing this data. And it also speaks to the fact that we're using what sometimes happens in these projects is, oh, we need a knowledge graph, we need ontologies. Get them all, get all the ontologies. We got to bring them all in. And well, it comes back to, what are you trying to do with the ontologies, right? And Semaphore I'm going to be honest with you, Semaphore might not be the best place to put all your ontologies. The ontologies already exist. What we're trying to do is use Semaphore for what it's really good at. So it's about evidence. It's about finding evidence for things in text and data. So we're bringing in that aspect of it. And then in the Progress Data Platform, the full ontologies with all their rich associations and axioms and classes can be in the data platform part of our system, the MarkLogic piece, or in some other data platform. The idea is the data is now marked. So the data is now transferable. You can put that data anywhere, and it can be associated with a graph. So it's not just about one platform here. We're trying to make the data more intelligent. So that's dealing with data. But then one of the aspects that may be forgotten or not considered is the messy unstructured text, right? And it's funny because that's where the business documents itself, right? That's where the business evidence is. That's where the stories are. That's where the narrative is. That's what actually, gets approved. And so often documents are treated as chunks. It's always bugged me as a librarian that throughout my career I hear, oh, documents, it's just a blob, right? It's just a blob. Or now or it's unstructured. Sorry. Yeah, I mean, language has a lot of structure. If AI has taught us anything, our language has a lot of structure, right? And what's the other one? Blob, yeah, and chunking for AI. Oh, documents, let's chunk them up. Let's chunk them up and throw them in. Maybe we'll get a good answer or something. So you have to take your documents seriously, and that's why it works so well with the Progress Data Platform, because we have a legacy of working with documents. We treat them with respect. We can understand the structure. We can manage them. So when you're dealing with bringing in documents, and especially in a regulated industry, you need to think of these things. So often there's a process called graph rag. I'm not sure it's the best terminology for this, but the idea is, let's just get the graph out of the data, out of the documents. Documents are messy. Let's extract the data, and then we'll be done with the documents. So we'll send an AI or send an LLM into documents. We'll extract all the data points, and we'll throw that into the graph, and forget about the documents. We've got the data. But that's really, it creates yet another black box. It creates another kind of obscure source of information in the graph that's hard to validate, it's hard to govern. And really, most importantly, it's generated without first considering what are the requirements. What are you trying to do with this information? So when Semaphore and MarkLogic work with this information, we try to retain as much of that document as we can. If you're getting access to these documents, we can tag them. We can find specific business driven requirements for data in these documents. We can be very specific and repeatable. It's not probabilistic. We're trying to find the key data that's necessary and bring that into the graph. But don't forget about the documents. We can do a lot more with those documents. Drew showed some of the analytics dashboard. Well, what if you're not just pulling in the data that you're looking for in a graph, but since you're there, bring in the most commonly occurring phrases, bring in the entities, do some of the mining there, and store that. If you can store the document itself, sometimes you can't, but if you can, store the document. Store the parts of the document that you can store, that you're allowed to store. Include the permissions, include the security that, like Drew mentioned, to make sure that all the documents are used correctly. And so that you can go back and get more metadata. As your business requirements change, look at the data, look at the document again. Don't try to mine the heck out of the documents just in case some question comes up where you need it. What are your questions? What are you trying to find? Mine the data, change your question, get more data, retag, reassess the graph. So really what we're showing here is something we think is a little different from maybe a common approach. The knowledge model isn't just connecting data. It's deliberately extracting and generating structured knowledge from and about the documents to help complete the graph. We're modeling context. We're modeling business requirements. That's always how a Semaphore project starts, is what are you trying to do? And then let's build the structures and the capabilities to support that. So yeah, once you have the documents, you don't have to get rid of them. But I'm talking documents up a lot, but they are just snapshots. They're a source of knowledge, but they're a source of knowledge from a particular point in time. So that's the power of having a knowledge model aside the documents, because knowledge models can change like this, especially if they're easy to use. And we'll talk about that in a second. If the knowledge models have to be accessible, have to be subject matter expert maintained, so that if there is some new point, you've created a new product, it belongs to a new category, you're exploring a different research area, add it to the graph. And it's there in the knowledge model. You don't have to wait for it to appear in a document, for example. So the takeaway here is the graph, isn't built for its own sake. It's built to serve the business questions that we need documents and data to answer. That's our focus.
Good question.
Oh, sure.
Talk about some methodologies that you use for your SMEs to update their knowledge graph, or have feedback.
We're going to go through that.
Awesome.
Yes, the knowledge graph has to continually learn. Yes, so that's it's a good point, because the documents and the data, you're actually, it's a dialogue with your users. It's a dialogue with your business with what's in those documents. That's one reason why you may not just want to get at the specific points that you need, but what else might be effective in improving the knowledge graph. What's most commonly occurring things that you see popping up, the trends in documents over time. How should that be fed back into the ontology for enhancement? Yeah, it's definitely part of the program. Yeah.
Do you see that in one industry more than the other, that the knowledge graph is changing like more continuously and more updates need to be needed?
It's really, when we work across, Progress has clients across every vertical. And I've worked on specific Gen AI RAG type solutions with this type of architecture. And it's pretty similar. I mean, certainly, in life sciences, ontologies are everywhere, and that's a problem in and of itself. There's so much of it. In other cases, maybe it's the models can be very simple, but just having a knowledge model at all improves how the AI, talking about enabling AI, it improves the trustworthiness, improves the reliability of it. We see this over and over again. It even shocks me that the model could be very simple, and yet it makes a huge difference because it's not just, defining a concept in response to a question to the AI. So you ask a question of the AI, you look at the model returns, the segment of the graph that's relevant to that question. But it's even just the fact that it's in your graph indicates that it's important. So somebody asks a big, long question, what is actually most important to the business according to the knowledge graph? That alone increases the relevance. I mean, and we've done comparing just using vectors versus comparing using this semantic approach with knowledge models. And the relevance just goes through the roof. It goes from, a standard 50%, up into 90, 95. What was, you mentioned the ADM one. What was that specific? What was the relevance?
Yeah, that was 99%.
99%.
Yeah, based on subject matter expert validation. So they had a set of 300 questions going through a corpus of documents and validating with their SMEs that adding the context using the knowledge graph greatly exceeded what the base LLM would do just with vector search.
Yeah. So along those lines, this next slide really it shows how these ideas show up in are exhibited in the design principles of Semaphore itself. So we're going to look at Semaphore in a little more detail when Drew comes up next. But I just wanted to kind of outline, what is it about Semaphore? And if you think about everything we just talked about, it has to be easy to use and easy to integrate. And this is what makes us so easy to jump into these AI projects, because the models can be quickly constructed, quickly applied, and quickly integrated with whatever framework you're using, whether you're using our framework that Drew was demonstrating or something else. Semaphore is designed so that you can apply its capabilities, whether it's access to knowledge models or taxonomies or ontologies, or access to its classification or content analysis capabilities. The APIs are all there. We have toolkits, and it's just intended to make your systems work better. The models are not just there to look at. And I mentioned that one project where they're bringing in so much information, it has to scale. It has to be able to not just handle large models with a lot of evidence and things like that, but it has to handle the processing of content effectively. So it's all part of Semaphore's build to be able to be scalable. And one thing, this is a tease to get us to come to our booth so we can show you Semaphore in a little more detail. We're adding a lot of really exciting features to Semaphore all the time, of course. But in these last few years, really the AI capabilities to help just within the modeling, how do you get AI to assist with building it? That's helped with these Gen AI cases as well, where, you need a model? Ask AI to help you build it. We have MCP servers for Semaphore that are coming out soon, where you can ask it to build a model for you, ask it to generate a model representing business requirements from a business strategy document, things like that. Really exciting capabilities. And so out of the box, Semaphore can do a lot, but it has to tailor to your business requirements. If you're doing something generic, Semaphore is still a great tool to use, but where Semaphore really shines, your business needs a particular type of perspective on your data, and that Semaphore can help realize. And just to make this a little more concrete, before Drew comes up and we actually look at some semaphore components, this is an architecture picture of semaphore. So just, we're talking about semaphore. Well, what is it? Well, it's three main capabilities, and they correspond to three applications that form the suite of semaphore. So across the top, you can see the models are the centric model management, whether you're reusing models from external sources, whether you're creating them on your own, whether you're generating them through AI or through some mining project, the model is the center. And it's everything you can do in semaphore, from designing strategies for classification or enhancing an AI project. It all happens in the model manager, and the model management is designed for ease of use. So a subject matter expert, not necessarily a taxonomist or an ontologist, although we don't chase them away. Ontologists are welcome to use semaphore. It can produce very sophisticated models. But so the model is the center, but then we use those. I like to say we put the models to work. They're not just sitting there in, dare I say, protege or something. The models have to be applicable. They have to be operationalized. So that's what these other two modules do there, where can you use the model to generate these text analytics rules, these classification and NLP based rules to analyze that content and add those specific tags to your data that makes it part of the graph. That's a very powerful part of the engine. That's what scales to be able to process millions or even billions of pieces of content. But the other part of the semaphore on the other side, if I'm doing the mirror image this side, is about making those models just available anywhere they're needed. And sure, you can say, well, can I just write Sparkle queries to do that or something like that? Yeah, if you want to take the time to do that, but our services for making the model available are instantaneous. They're RESTful calls. You ask, give me the tree, give me the hierarchy, give me everything related to this, give me a visualization of the entire model, whatever you need. There's a whole suite of capabilities in what we call the integration service. We saw some of it in Drew's demo with the facets and the concept descriptions coming up on the other side, things like that. So, and how are you going to feed the graph? How's your data appearing in the graph? That big graph of mesh, for example, that Drew was demonstrating. That's all coming from that integration service. So with that, I want to go back to Drew, and we'll just take a little dive into semaphore itself so you can see it through as it relates to Drew's earlier time.
Thanks, Jim. So the next thing we're going to look at is semaphore in action, as Jim highlighted, breaking it up into three main areas. We're going to focus in first on modeling. And this is where we would start to define what we call knowledge models. This could be an ontology, a taxonomy, a controlled vocabulary, or even a flat file that you pull in from one of your databases. A system typically manages multiple models. And again, this is where we take consideration and under security, where we limit access to each of the models based off of role-based access control. Going to take a look at the PubMed model. And this is an industry standard model. We can go to NIH, download it. It comes in Turtle format. We can load that in. But the point of the user interface, as Jim was highlighting, is about getting your subject matter experts involved, right? Having somebody hand code Turtle files or going into Protege that don't really understand this domain requires a lot of training. So we try to simplify that in the UI, but also expose APIs for this if you want to do it, the more technical way. So I'm just going to look up the term glucose in here. We have type ahead for the term. Looking at it at this particular term, we see it in a hierarchy. We understand that it has parents and it also has children, and it could have also related concepts. So this is where the knowledge graph starts to form, right? Understanding where does this core concept fall into the rest of the ecosystem. The details is where we leverage this information for contextualization. And Jim was saying something really important earlier. It's about the evidence. So when you're looking at content, you may have a preferred term in your organization, a product name, it may be early on in the stage of development, maybe only a code name or a chemical compound. We want to capture all that as part of that core concept, right? So in terms of glucose, we have various alternate labels. We have concept identifiers for other areas of the model of the ecosystem, and other terms and unique identifiers. So any of this bits of information can act as evidence towards categorizing and classifying something. The other aspect too of evidence are these relationships, right? So if you see multiple items hitting and firing, it could be a significant amount of evidence in there that this piece of content is talking about this core concept because it's talking about all these other related items. So this is where we start to model that bits of information out to use as part of a classification process. There was a question earlier on how does the SMEs interact with this system, right? So if you have a more advanced SME that wants to come in and manage the knowledge model, they can come in and start going through here and building them out. However, we have a concept called tasks, and this is more around workflow, where you can put a task into a review process and put out an additional user interface for an SME to come in where it's just a little easier for them without all the other information around it, right? So we may select a branch of the model that we want them to edit on, or have them come in and add additional terms, right? So we see in this case, we have a bunch of newly added terms. We can come in, add additional metadata, alternate labels, descriptors, and things like this. And this is for an SME. They're just filling out a web form, right? It's nothing too crazy. But again, we have those integration services and APIs. That is where we can start to capture the user's intent from the questions that they're asking against the agents, right? So in that case, we start to intercept those terms that the AI is identifying and put them into the same workflow where your SMEs can validate them and understand whether they want to keep them, reject the terms, or add them into the model. We could take a look at beta cells, for example, right? And we can see the note that is associated with this based off of a question that came in through the chat interface. So they can accept and decline these terms or add them into the model. So once we're happy with the model, there's a publishing process that we publish this out. And that is a snapshot of the model for two reasons. One, for integration services, where we show the data visualizations. So if you have a consuming application, they're seeing that prepared and approved model. And also classification. And classification is pretty interesting. Typically, when you're thinking about auto classification, it has to do with natural language processing and named entity recognition. We do that, but we go a step further where we apply that evidence that we defined in the knowledge model to find terms within the text. So if I send this article for classification, it lights up with all the concepts that were defined in our model. That's a little busy, so I'll go back and let's look at just a couple of ones that we were talking about in our question in the demo. So we were looking at glucose and the GLP-1s, right? Glucogen-like peptide 1 is the preferred term. This is what Mesh says it should be, but we have other information in here, like alternate labels and supporting information that points to a high probability that this concept is in here. Yes?
These concepts were predefined and you already identified them in the program?
Correct. So in this case, these concepts were loaded in from an industry standard model. The models can be anything you want. It could be, you can bring them in from an industry standard one, or you can build one based off of your domain as well. In this case too, we have some compound words like blood glucose that are associated with glucose monitoring and things like that. We could also dive into the semantic analysis of the actual content, looking for things like named entities, parts of speech, stemming and lemmatization of terms. And this also is pretty interesting if we look at content in a text mining capability. And this is one of the areas too that could help you build these models, is that you have a rich corpus of content in your ecosystem. Let's start to mine those and look for terms. And then we can also do paradigms on that, like term co-occurrences, as well as vector similarities on these extracted noun phrases to influence what goes into our model. So we walked through the bits of how we're going to govern this information, right? How we're going to add that context into the records, how we're going to make sure that we have enough information in there to discover it, right? So let's talk about integrating this data now. Now that you have a process to classify things, you have a model that's well governed, et cetera. Now you look back at where you work and you realize that, wow, that information's everywhere, right? There's data sprawl. It's in all different shapes, forms, whether it's in tables, maybe on file systems somewhere, maybe in an index. It may just be institutional knowledge in somebody's head that you want to record, right? And this is where databases have been around for a long time trying to do this, right? Relational data stores, highly structured, rows and columns, fantastic at modeling those types of applications. It would have not stood the test of time if it wasn't, right? But there are certain limitations to them, right? It's hard to deal with unstructured or semi-structured content in a relational store, as Jim was heated about before, calling your documents blobs, and just shoving it in a cell is not really a way to handle them, right? And it could be difficult to even find content in there. So in came document databases and search indexes, where it's effective at modeling these hierarchical structures. You have XML, you have JSON, you have capabilities even with extracting from things like PDFs and Word docs and building HTML representations and storing those in document databases. And then in terms of text search and discovery, search indexes are really good at understanding things like tokenization, lemmatization, stemming of terms, and finding content in a relevant form, right? But these applications also have a bit of difficulty expressing long chains of facts, information, and also inferencing, right? So in came graph databases, right? Graph databases excel at those things, as we all know. That's why we're here, right? We can build really interesting models within graph databases, do large-scale traversals of information, infer new facts. But at the end of the day, sometimes it becomes difficult to recompose those structures, right? Where you're breaking things apart, adding them to the graph, as some people would have done, breaking them apart and adding them into the relational store, right? So what we want to do is blend these together. So when we take a multi-model approach, what we look at is when we're dealing with a lot of heterogeneous data, or we want to store a lot of contextual metadata with records, or we don't know what the schema is up front, and we want to kind of do like a data discovery and look around. Documents make sense there, right? There's search paradigms, there's tooling around these areas. We could start to integrate without major ETL. You may have heard of ELT processes where you bring content in and then iteratively transform it and build up your data model. And that works out pretty well for a lot of use cases starting out. And then when you want to model with graphs is when we're starting to look at storing facts about your data as that contextual information we saw coming out in our classifications. We may have industry standard knowledge domains, right, that we want to bring in, whether it's chemical compounds, financial instruments, et cetera, right? Or if we want to infer new information based off of items that are in that graph, right? We can start to really harness the power of that information in graph. So going with a multi-model approach and using each of these formats for the appropriate shape really unlocks an interesting paradigm, right? You can store your business entities and you can start to build rich relationships between documents using those classifications, categorizations, and knowledge graphs, right? You can start to build up complex queries for finding data by mixing facts, information, and metadata all together to really target the information that you're looking for. And then with our particular offering here is that we simplify the integration by using a unified platform. You don't have to select upfront whether you want a graph database, you want a document database, or a relational store. We store everything in one system, a single transaction, single security model, so we can cross-query it. And this is where we're going to jump in a little bit into what we call the Optic API, where once that data is in the system, it could be metadata, it could be the actual records. So we can do a sliding scale on that information. But when we can start to query it, and the information has its own particular models and query languages that are industry standard, right? We implement a triple store and that's RDF compliant. So we use Sparkle for searching against our graphs. We have geospatial indexes within there. So if you want to target something that's within a 10-mile radius, for example, right? We have SQL capabilities as well as search capabilities and vector, specialized vector indexes. So you can use what model is best for that type of data that you're managing and then cross-query it. And we offer data accessors, joins, and aggregations across all those so we can start to compose a multi-model query in one pipeline. Part of this is enabled through a process that we call template-driven extraction. And what that is a simplified configuration file or template that sits within our schemas that says parts of documents get projected, right? You can store your graphs natively, you can store rows and key value pairs natively, but when we want to start to link things together across these models, template-driven extraction really helps, and we're going to go a little bit into the code level on that in a second. So we can take that document, project things out into the graph, and tie a document to a knowledge graph, right? Or we can project things out of that document and tie it to a relational view for access via a BI tool, for example. And understanding that developers that interact with the systems have all different languages that they like to integrate with. We have SDKs in JavaScript, xQuery, our Optic DSL if you want to just go over REST, as well as clients for Java, Node, and Python. So now we're actually going to really dig in deep and what's the core of writing a multi-model query. In this case, we're going to look at it in JavaScript. So as we were saying earlier, the system's multi-model. So we're going to look for a particular article in a collection using search. And we found an XML document. And this XML document has a lot of rich metadata in it, right? It's coming from the NIH. It's a published piece of work. We have things like completion dates and the journals that they were in, all interesting things that we can start to aggregate. It also has classifications in it, right? So if we look a little deeper in here, we'll see identifiers for chemical compounds, identifiers for the mesh terms, etc. So let's look at this article in a graph view. We can see the titles, the identifiers, and all the references that this article is referring to. So when we look at the knowledge graph, we don't have to pull out every single bit of information from the article to put in the graph. because those knowledge models and those industry standards have that rich metadata ready within them. So what we're doing is defining a template to do that. And through a template, we define a context. We're looking at the root of that XML document, a particular collection within this namespace. And then we're going to build up those triples, right? So we have a subject, a predicate, and an object. In this case, we're pulling a title out. In this case, we're pulling the record identifier. And in this case, we're going to go down into our classifications and start to pull out the citations. So if I run this, we see the titles, the identifiers, and the references. Looking at the knowledge graph itself, they look a little more familiar to folks, the standard Sparkle. We're going to look for those distinct terms as we went through in classification earlier. I'll pull that actually up one more time. We can send over questions and also identify the key terms. Glucose, GLP-1s, right? Whether we're using a code or the actual term. So now we know the concept identifiers for this, and we can go in and look those up in our graph. In this case, I'm going to start to pull the preferred labels and alternate labels for these terms, right? So we have the context of that question. We can also add in other relationships into the Sparkle query, build an additional context, and add that to the context of the LLM when we're trying to answer a question. But this also helps out in our lexical searching. So now we know that based off our business requirements and how our business thinks about these core concepts, what are the textual representations that can appear anywhere within these records? So in this document, in documents, we can look at for those particular labels using lexical search. In this case, we're going to use the accessor from search docs and give it a scoring methodology of BM25. By default, it's TF-IDF, but BM25 takes into consideration the length of the records. In this case, we're looking at chunks instead of the XML records. And these are the JSON representations. So we're going to pull those chunks to add into the context as well. And you'll see also some of that semaphore classification on those records to add the context into the documents. Enabling vector querying is as simple as defining a TD. So as we have those records and documents in the database, we can have vectors and multiple vectors within a record, right? So you may have a single document and you may be trying different embedding models as your tests. In this case, we're going to target a particular property within our JSON record and tell it it's a vector. It's important to also include the dimension using based off the embedding model you've used, because that's going to create the specialized index. But also when you're searching against them and retrieving those, you want to retrieve the same parity based off the question vector that you're using, along with the vector that's within your content. So I pre-computed a vector for my question that we asked earlier. What is the effect on glucose while using GLP-1 medications? It's a very long vectorization of floating point numbers. And we can start to do things like ANN and KNN queries. In this case, we're going to look at for all our chunks that semantically match this vector. And if we search for this, we can see the content coming around back for content that's relevant to diabetes, GLP-1 medications, etc. So if you just need to do vector search, really quick, just run your content through an embedding model and start to enable this. But what we really want to do is hybrid querying. So in this case, we have our vector. We're going to build up that vector search plan and find those bits of information. We're also going to pull a graph plan, right? We classified our incoming question and we know exactly what parts of the graph to go to for those key concepts and information. We're going to build our lexical plan so we have relevancy order. And then finally, we're going to join all these. We're going to do an outer join across all these different models because there could be misses based off of each one of these paradigms, right? The lexical search may not find anything because that keyword doesn't exist in the article. The vector search may not find something because it's that particular embedding model didn't know the terminology of your internal business. So we're going to create a hybrid query here and create a hybrid score and reorder those by our new hybrid score. So now when we look for content, we have a weighted score with the most relevant content up to the top, and that's what we provide to the LLMs. Yep, question.
Do you control over the weighting?
Yes. Yeah, so you have control over the weighting on two factors. One, on the lexical search, you can control the weighting on terms going into your query. So you can weight more terms, rank and boost certain terms that are going in. You can also tweak the weighting on the BM25 factors for document lengths. And then on the vector search side, you can affect the weighting by the vector distance weight too. So you can weight those. And when you do the hybrid score, there's another area too there. If you want to influence how those scores are computed, you can influence that. We give a pretty, in our documentation, this is one of the standard kind of ways to do it. You may have seen processes like reciprocal rank fusion and things, stuff like that, where you do some additional things. You can implement that too with our weighting algorithms as well. So in a nutshell, the knowledge graphs here is an enabling factor to really find your information and add context into what you're looking for. So it helps you govern, it helps you add that context. And since we put all those other pieces up front in terms of the content preparation, the security, the auditability and tracking, we know if in an event that somebody asks us to prove how we got to this answer, we can say that these records were supplied to the LLM. The content lifecycle was X, right? Going through this process. We have the audit trails for things. We know who asked the question, what, when, where, and we can even say how we computed those retrieval factors. So, this is one of the ways of how we brought our process from kind of more of a science experiment in particular areas of the business to production grade retrieval systems. All right. So I know that was a lot to cover and may not have been as hands-on as you would like, but if you'd like to get hands-on, we're offering a 30-day free trial of our Progress Data Platform in the cloud, which is known as Progress Data Cloud. It includes what you saw here today in terms of Semaphore and the multi-model database engine. You can use your own UI frameworks to build things out, etc. Please come up to the booth and talk to any one of us. If you don't have time today, on the Progress website, there are white papers and blog articles that walk you through the whole process, including code for LangChain to how to work this pipeline up, as well as other materials if you're interested in just one component of this workflow. And here are our contact information for Jim, myself, and our colleague Andrew that is somewhere in the room over there that will be at the booth later. If you want to reach out, if you have any questions or looking for any additional information. And with that, you got 15 minutes for questions if anyone wants to grill us.
Do you have any examples of when a client had a metadata repository that you now enriched with the knowledge graph, the model.
Yes, so we can share also on the website, there are a great number of webinars as well as use cases and white papers. We have a yearly summit called Progress Data Summit. Last year, the ADM team presented on that, and they used that exact workflow. Doing this pipeline in iterative fashion, bringing in their research data, emails, correspondences, SharePoint data, organizing it and making it searchable, but then also creating a model specifically for PII and GDPR constraints, right? To analyze content to see if there's anything sensitive in those. So not only you can use this for chemical things, you can use it for security and auditing capabilities as well. And they walk through their life cycle in that. So that is a really good area where we can do that. The other side of things with that is you don't necessarily need to bring in the full records, right? You can bring in just enough for indexing to do that searching. And what Jim was highlighting before with Semaphore, it's all API driven. So those results are ephemeral. So you can bring them in and store them in the Progress Data Platform and integrate this all in one solution. But you could also take that and feed a downstream system, right? We have customers that actually use Semaphore for a lot of classification and insert that information back into Microsoft Purview, for example, for for regulatory reasons and things like that.
Thank you.
Okay. Any other questions? All right. Well, thanks.